Yeah? All right. Can you hear me? Yeah? Well, yeah, everyone? So, good evening. Thank you for coming. I'm Victor Tozo. I'm here to talk about VDI in KubeVirt. What the goal of this presentation is to tell a little bit about what's the current state of the affairs, what works well, what doesn't, and plans for the future. So, first of all, who am I? I worked in SPICE for a little bit over four years. SPICE, I don't know if you know, it's this remote protocol that used to, it still does work well. I was in the Virt team in Red Hat for quite a while. Nowadays I'm working in the KubeVirt infrastructure team. And yeah, I'm working in KubeVirt more or less since 2020, and I'm a reviewer there since 2024. So, what is VDI? Acronyms, right? Like, so virtual desktop infrastructure. For the purpose of this talk, like trying to narrow down what it is the technology to allow you to remote access the virtual machine. Yeah, everything that is needed for that to work well. It's key to understand that integration with the hypervisor is important. So the hypervisor, for instance, in the context of this talk, in the QEMU environment, is QEMU. And yeah, we will have to integrate to display, keyboard, and anything else that QEMU provides as interfaces. And not guest resources. So, because there is also the option of accessing a remote machine inside of the operating system, right? This is not the case. With VDI, we are talking about the hypervisor level and the host. Yeah, talking about VDI, there is also always a little bit of confusion and understanding about remote protocols as well. So VDI uses remote protocols, but remote protocols are not VDI, right? So I have two examples here running SPICE, like from the left, Linux machine connecting to Windows 7, and on the right, a Windows machine connecting to other machines. And the idea is that for the remote protocol, it doesn't matter where the VM is running. If it's actually in the guest, it doesn't even matter if it's a guest or not, running like a VNC server inside of the guest. Only matters that the protocol is being implemented properly so you can access. And yeah, on the application level, you see it's like just another application, but in fact is remotely accessing VM. So this is the common case when we are talking about VDI, and in the case specifically of QEMU. So we have QEMU, it runs a guest operation system, the apps inside of the guest, but QEMU itself also runs a VNC server. It has access. It has a VNC server integrated with it. We can access the guest using that. So it exports the VNC server on a port that you can configure. Here is like a 5900, so which is the usual. And then a VNC client can connect to it. Now, so far so good. I didn't explain anything about KubeVirt, for instance, kind of expecting that people know. But yeah, if you do, just raise your hand, otherwise it gets confusing. But in short, like KubeVirt is basically the way of running VMs in Kubernetes, installing and making it as native as possible for Kubernetes users to run workloads as VMs in Kubernetes. Now, about VDI in KubeVirt today, and for quite some time actually, since the inception of KubeVirt, the goal of VDI in KubeVirt is actually for troubleshooting. It has not been a priority to make that first-class citizen VDI solution, which is, of course, it's something that it's becoming more of a problem, right? Like we are having more and more users since, let's say, a company bought another one recently. They are interested in having more and more VDI solutions in KubeVirt, or products that embed KubeVirt. And this is one of the reasons that I'm here today, to start taking a step forward into how to improve the situation in KubeVirt. So yeah, main goal is troubleshooting. We use QEMU VNC server, so it's what QEMU gives us basically, and the access is over virt-api. I'll show how it works, but this is also another problem. Yeah. So what you see here, I didn't, provide a full load of components of Kubernetes or KubeVirt, but I just want to pinpoint the main actors of VNC over virt-api in KubeVirt. So you have there, in green is the virt launcher pod, and it runs then, it has containers inside of it. One of them is the virt launcher container, the compute container that runs QEMU, libvirt, and such. And let's say that someone wants to access this remote machine over VNC. So what the path forward today, what we have today, is a sub-resource for VNC. So we use the virt-api, which is providing the sub-resource for us. So basically what we need is the namespace that the VM is running and the VMI name. So with just these two, the process as it follows, right? The client will ask, I want the VNC connection of this namespace plus VM. The virt-api will receive this request and forward it to virt-handler. Virt-handler is our daemon set in KubeVirt, so it has high privileges. So basically this is, what I'm saying is that in a cluster, virt-api will forward the request to the right node, to the right host, and then virt-handler will receive the request and will connect to this VNC server, which is exposed as a Unix socket in the node. And virt-handler will make then this connection between the HTTP request, the REST request, and the Unix socket, making a web socket. Main issue here is that the data flow of the WebSocket will be the same as you see now, and this can become a problem, overloading or the virt-api path. So, as I said, the first problem of this approach is the data path. It does not scale well, and for that reason, since the inception, we define that it's for troubleshooting. And for troubleshooting, this is fine. We are just accessing the VM for why it's not booting, what's the problem there. And for that reason, yes, one single connection per VM. That's what we allow. So we actually deny or remove. It was till recently we actually removed the VNC connection that already exists. We would drop that one, get the newer request will take over. But now it's we have options for that not to happen. And another issue of this approach is that we don't have an easy way to add new protocols. So basically we are getting what QEMU provides to us, and let's say that QEMU provides a different one, actually does SPICE for instance. So we have to create a whole path for that new protocol or other protocols to exist, and that's a problem, right? Like it brings a lot of coding to the factory. You want to reduce how long it takes for someone to access this feature, this new feature. And that comes to the possible solution. So QEMU, since early 2022, provides this display dbus interface. So what does it mean, right? Dbus is something that someone not knows what dbus is? Okay, it's a peer-to-peer IPC protocol, right? So between processes you can make a communication. They can talk with each other. So what this means in this case is that QEMU will export all the VDI interfaces over this dbus interface. So now it will allow other processes outside of QEMU, outside of Virt Launcher in this case, to connect and expose the graphical, the keyboard, everything as it will, as it wants. So this is a great possible solution that I implemented a proof of concept that I will show shortly. But first, how it would work. or at least how I'm proposing now, at least what's implemented. Yes. So, as I said, like the idea is that QEMU now will expose this VDI interface over dbus. So the green actor here, which is the virt launcher pod, no, the virt launcher container. Sorry, I forgot to draw the pod, but both the blue and the green are running on the same pod in this case. So the virt launcher container now does not need to expose the VNC server. It just needs to connect to the Unix socket. And the blue one is a sidecar container that I have launched. And this sidecar container, because in the virt launcher by default it does not have the bus, so I included the bus daemon in the sidecar. So what I'm doing here is like the blue container runs first, because this is how the hook API in KubeVirt works. It creates all the environment for this for QEMU to connect, and it will also change QEMU and libvirt. Using libvirt, it will change QEMU to use the display dbus. So this is actually not too difficult to test on your own if you want. So yes, so I'm proposing to have a sidecar at this moment, but in the future the idea is to have actually a VDI sidecar. This VDI sidecar, in this example, for instance, is running VNC, and it will connect to the dbus interface, so it will get what QEMU provides as a VDI interface, a VDI data, and it will expose as it wants, right? In this case, I use the service object for Kubernetes, so this also provides the possibility to avoid going through the virt-api and some flexibility. Again, this is a proof of concept, so all the details on how this actually have to be implemented needs to be discussed still. Yes, interesting. The VNC server, in this case, it needs somewhat to be able to connect to the bus and then feed the VNC server with the data, right? Like keyboard, display, and such. So what I'm using here is this repo from my colleague that he implemented all in Rust. This VNC server that connects over the bus, and that's it. So the VNC server here is different from the one before. The one before is running is the QEMU one that you can get with -VNC. In this case, now I'm running another container. It's another process, and it's running this Rust VNC server, and then it communicates with QEMU over dbus. I have a demo. It's not long, it's 1 minute. So I will just quickly go. I hope you can see, sorry. But it's also in the link. What I did here, yeah, it's as I said, right? So because, yeah, in a minute, you see that QEMU VNC and QEMU RDP are the binaries that connect over the bus and expose VNC and RDP in this case. So I actually did both. I'm exposed that's a remote viewer connecting over VNC to the VMI. And I use a server subject and the port forward for locally connecting. Now for RDP, actually needs credentials. So I had to connect to the pod and set the credentials there. In this case, the user, secret, and the domain is home lab. Now I can run GNOME connections, which is the RDP client that I had at the time, and set those and connect over RDP. Yeah, and it's the same VMI, it's the same thing. So this is the plan, the proposal that I want for forward. I think there are several benefits that I didn't put in the next slide, but let's say now we can have, as I said, like we can go without you passing the virt-api, so not putting the burden of the data path over the Kubernetes API path. We can start having different remote protocols as well. So as I showed, RDP is possible. This dbus thing is already for quite some time. So there are quite a few possibilities. And one that I care a lot is the being able to provide third-party solutions, right? You can provide your own container for VDI and run. It's only needed, it's only needed for you to be able to speak with the bus. So as long as you do, you can expose whatever protocol you want with minimal changes to KubeVirt. So I think that's great for the future. Now, other possibilities as well for, it's not really VDI, but it's something that it's well established as well as using in-guest solutions. So for instance, GNOME nowadays with Mutter, you can have even the bus APIs there as well, but you can have RDP or VNC server. And take one step back. One of the benefits of VDI itself that I mentioned is that the guest operation system does not need network, right? You can connect through it directly to QEMU. But in general, with RDP or VNC server running in the guest, you need internet. You need networking access. So doing something like using vSock, we can actually connect the running server in the guest to the host and do some sort of bridging as well. So it's another possibility that I heard and discussed before. Benefits, it's that it mostly uses guest resources for everything. And it would work even without the guest network. As I mentioned, like there are some Mutter APIs and things like that. Perhaps we can do some bridging as well between them, but it's more like afterthought. So, takeaways. Yes, today KubeVirt, VDI in KubeVirt is for troubleshooting. That's very important. Discussions for improvements is always welcome, but today that's the case. Using display over dbus, it's very doable in reasonable time. It took a week to get this proof of concept in place. And of course, you need to do the VAP and discussions upstream, but the technology is already there. And I didn't show any code because it's mostly container files, like creating things and connecting things that already exist. And allowing other protocols and third-party integrations. And of course, in-guest solutions is always a possibility too, although I don't see anyone pushing forward to that today. And that's it. Any questions? Yeah. Yeah, that's a cool question. So the question was if we can use GPU acceleration. So that's another point for discussion in the case of how that would work, because the container would need the GPU, right, the server. So let's say VNC wants to extreme H.264 and needs GPU support for that. It will need how we'll fit this allocation of the GPU for the container in that pod.
Is that how you meaning you need the GPU for the question for VNC, or is it for the application guest?
In both cases, if you have the GPU for the VM, then that means that the VM already sees, the operation system already sees the GPU, and it's what is running there, it will use it. But if we're talking about in-host, that in the same layer as QEMU, now we have a GPU allocated to that pod. Is it a GPU for the VM to use, or is it for the side container to use? So this is the kind of thing that needs, but it's definitely doable. Yeah. All right. Thank you for the question. Yes. If the bus would printers. Okay. Yeah. Cool question. Yeah, no, that's actually a great idea. Like if you can expose, I don't know the use case. Perhaps that's perhaps something interesting to think about. So the question was, can I use the bus interface from the guest to do things that usually you do with the guest, like exporting printers, doing printing? Yeah, I think it's a possibility, yes, to do this kind of export. It's not necessarily related to the VDI or this, but I think it's not difficult. Yeah? No, sorry, I missed the comment. the KubeVirt?
Yeah. For example, if I have the environment in the virtual machine on premise and I want to migrate to Kubernetes, it's faster or easier to, in the middle, use the KubeVirt, or probably I will go...
About migration then.
Oh, yeah.
So the question was, if I have a VM on-premise and I want to migrate to KubeVirt,
For example,
or you're already using KubeVirt on-premise and you want to migrate some cluster. Yeah, so there are several projects. There's Forklift, for instance, that does this kind of migrations. They take VMware and move to other. Yeah, so you can try to use those things, but you have to see the use case. Migrating is not trivial work. It's not. It has to be careful because otherwise you may lose data or the workload. Yeah.
but our VM is for environment, for example, VM for providing some software, and we want to go to Kubernetes. But I think
Yeah, KubeVirt runs on Kubernetes. So it's a matter of how you do the workload that you have today running on KubeVirt, and there are a few ways of doing that. Yes, if you want, I can show you. Yeah. Well, I didn't get the question. Okay. So it's basically feature parity. So let's say you are passing through something, some device in your on-premise solution. If you can have it on KubeVirt, it really depends. So it really depends if what you are doing and how you use it. Yeah. Perhaps you have to adapt some stuff. Yeah. All right. Any further questions? Okay. So thank you.